This is, I think, another question on number 47 on section 6.6. And I don't believe I'm going to be doing 47 for you because it was done in class as one of my examples. So I decided just to go ahead and give you another type of problem that's, you look in 47, it won't look like this one. But this one's actually probably a little bit more difficult than 47. And I didn't give you too many problems like this one anyway. So I decided to give you one like this here. So, but anyway. So this is 8 raised to the 1 minus x, which is exponential, and 5 to the x plus 2, which is also exponential. So this was an exponential type of exponential. This is category 3 problem. Remember, we had multiple logs on one side, multiple logs on the other side. That was category 1. Um, the second category with multiple logs on one side and a number on the other side. And this side is when you have exponential equaling an exponential. And to solve this type of problem, it's very simple, but the algebra part of it, it's the actual calculating the x once you've done the new portion of this type of a problem. That's the easy part. It's the actual getting the x isolated, and that's math 103. That's the hard part, actually. So on this one right here, what you got to do is you have to take the natural log of both sides. And the reason you do that is so you can use the power rule. So if you take the natural log of this side, the 1 minus x comes down as a factor. And you got to take the natural log of this side, the x plus 2 comes down as a factor. And once you bring those down, then it's just math 103, really. It's just isolating the x. So the natural log of 8 to the 1 minus x equals the natural log of 5 to the x plus 2. And so the 1 minus x is written as a factor in front, and the x plus 2 is written as a factor in front. So there's x's on both sides. So you're going to distribute the natural log of 8, which is going to be 1 times the natural log of 8, which is the natural log of 8, negative x times the natural log of 8. So distribute the natural log of 8, and equals, and then distribute the natural log of 5, so it's x times the natural log of 5 plus 2 times the natural log of 5. Now, what you're going to do is, if you notice, there are x's on both sides, and you have to isolate the x. This is the hard part. This is what causes a lot of people trouble, because they have 4 terms and they don't know where to begin with them. You just got to remember, like things stick together. So these have x's, these have x's, so they stick together. These two do not have x's, so they stick together. So you put them on one side, and the other one's on the other side. So what I'm going to do is I'm going to take this term and move it over here. So you get x natural log of 5, which stays put, and then add x natural log of 8. Then the 2 natural log of 5 goes over here because it does not have an x in it. So it becomes the natural log of 8 minus 2 natural log of 5. Now, so basically you're just playing musical chairs with these 2 terms. And the reason you do that is because you want the x terms by itself. Now you got to remember, you're trying to isolate the x, and the only way you're going to isolate the x is turn the 2 x's into 1 x. And the only way that happens is if you factor the x out. So x times the natural log of 5 plus natural log of 8 equals the natural log of 8 minus 2 natural log of 5. And so then to isolate the x, you divide by the quantity natural log of 5 plus the natural log of 8. So x is equals to the natural log of 8 minus 2 natural log of 5 over the natural log of 5 plus the natural log of 8. Now, a lot of people will just say, okay, fine, give me the calculator. And you can do that. If you're one of those people who like to do less keystrokes, but a little bit more thinking, which I'm one of them, because usually when I pull out my calculator, I usually, sometimes mispunch a number, so I don't pay attention to what I'm doing. And so what I would suggest, if you're one of those type of people, is put these 2 together with the product rule. So the bottom is really the natural log of 40. And I can cause less trouble on a calculator by punching natural log of 40 than natural log of 5 plus the natural log of 8, because this is the product rule. And on the top, it's the natural log of 8 minus the natural log of 25. So now on my test, I don't really care if you leave it this way or this way. From this point on, it's just a matter of, for the decimal, it's just getting the decimal is what I'm doing. So if you want to leave the exact answer this way, or even this next way, x equals the natural log of 8 over 25 divided by the natural log of 40. Natural log of 8 minus the natural log of 25 is the natural log of the quotient. I mean, you just use the quotient rule. So if you'd rather plug this into the calculator, which I would do that one. Just be very careful if you decide to do this one, because some people say, well, I don't want to do this, I don't want to do this. Then I would strongly suggest that you start putting parentheses around it early and don't leave them off, because that's the biggest mistake people make. They'll get the exact answer, but they don't get the calculator, the decimal portion correct, because they punch it into your calculator incorrectly. So calculator only going to give you the right answer if you punch it in the right way. So anyway, the decimal for that one, just so you know, is going to be natural log, and I'm going to use this last one, parentheses, 8 divided by 25 divided by the natural log of 40. And the natural log does put the parentheses automatically in there for you. And I have negative 0.309. I think they say round to 3 decimal places in the book, so that's what I did. Actually, my calculator says negative 3.3088835 and then 78. So that's what all the digits on my calculator has. But rounded to 3 decimal places, 0.309, and it's negative too. So, all right. And so this is problem number 47 and 6.6. But you got to understand, these are just two exponential functions, and it would work the same way if you had an exponential equaling a number. You take the natural log of both sides. And the reason for the natural log of both sides, remember, is to bring the exponents down as factors. That is the first step in on these types of problems. So once you run them from exponents down to factors, then it's old news. Math 103 can do it for you. Of course, granted that you never saw any of these things in Math 103, I know that. But it's just, but when I say Math 103, I mean just manipulation. You're just manipulating them to get the x by itself. Distributing, factoring something out, those are all Math 103 terminology. So, but anyway, for this answer is negative 0.309. That's it.